Hey everyone, ever wished your robot vacuum could, like, understand, clean under that table?
Yeah.
The one on the left of the bookshelf?
Uh-huh. Yeah.
Well, get this. AI is getting closer to that kind of spatial reasoning.
It really is.
Today we're diving into some seriously cool research about how AI is learning to actually understand 3D scenes.
Mm-hmm.
Not just recognize objects, but actually get the relationships between them.
It's pretty mind-blowing stuff.
Yeah.
The paper we're looking at today is 3DGraphLLM, combining semantic graphs and large language models for 3D scene understanding.
Okay, so I know LLMs are behind all those chatbots we've been hearing so much about, but how do they fit into, like, the 3D world? This is where I need the expert to break it down for me.
Okay, well, think of it like this. Chatbots use LLMs to understand language, but this research takes those LLMs and teaches them a new language.
Okay.
The language of 3D space and relationship.
So it's like teaching a chatbot to read a blueprint instead of a text message.
Exactly.
Got it.
And the blueprint in this case is what's called a 3D scene graph. Imagine a map of a room, but instead of just showing walls and furniture, it also includes information like the lamp is on the table or the chair is behind the desk.
Ah, so it's not just identifying a chair,
Right.
but it's knowing where that chair is in relation to everything else.
Precisely. That's what makes this research so innovative.
Okay.
It's combining those scene graphs with LLMs to tackle tasks like identifying objects from descriptions, writing captions for 3D scenes, and even answering questions about what's happening in a scene.
Okay, but don't our brains kind of do that automatically?
Yeah.
Why is this so hard for AI?
You're right. We take it for granted. But for AI, this is cutting edge stuff.
Yeah.
We experience the world from a specific viewpoint with
Right.
a body that moves through space.
Uh-huh.
AI, on the other hand, doesn't have that embodied understanding yet.
Right.
It's learning spatial relationships in a more abstract way.
So it's like AI is still missing that gut feeling of, I'm standing here and that thing is over there.
Exactly. And that's one of the big challenges that they're tackling.
Okay.
Now, the way they're doing this is through a new method that they've called 3DGraphLLM.
Okay.
It's all about teaching LLMs to understand these spatial relationships.
All right. I'm intrigued. Give me the download on this 3D Graph LLM. What makes it so special?
Well, one of the coolest things is how they've tackled the issue of complexity.
Okay.
Imagine feeding an AI information about every single object and relationship in a cluttered room. It would be overwhelming.
Oh, yeah, for sure.
So they've come up with this clever trick called subgraphs.
Okay, hold on. Subgraphs. I'm going to need you to break that down for me.
Imagine you're looking for your keys.
Okay.
You wouldn't search your entire house, right?
Right.
You'd focus on the places where keys usually are.
Yeah.
Your pockets, by the door, maybe under the couch cushions. Subgraphs are like that for AI. They focus the LLM's attention on the most relevant object relationships for a given task.
So it's like giving the AI a shortcut to find the answer faster.
Exactly.
Got it.
And this makes the whole process much more efficient.
Smart. So all this fancy footwork must lead to some pretty impressive results, right? I mean, can it actually tidy my room yet?
Haha, not quite room tidying yet.
Okay.
But they did test 3DGraphLLM on some benchmark data sets.
Okay.
These are like standardized tests for AI, measuring how well it understands 3D scenes.
And how did it do? Give me the highlights.
It actually outperformed other LLM approaches on several key tasks.
Oh, wow.
For example, on the object grounding task, it was able to correctly identify objects based on really complex descriptions, like the chair behind the desk to the left of the bookshelf.
Wow, that's pretty impressive. So it's like AI is finally starting to see the world in a way that's closer to how we experience it.
You got it.
Okay.
And what's even cooler is that they're pushing beyond just identifying objects.
Oh, really?
They're exploring something called functional queries, where the AI has to understand not just what an object is, but what it's for.
Okay, now that sounds fascinating. What kind of functional queries are we talking about? Give me an example.
Well, imagine you showed this AI a picture of a hotel room.
Okay.
It could not only identify the bed, the nightstand, the TV, but it could also understand that this is a place for sleeping, not for cooking dinner.
So it's like the AI is starting to develop a rudimentary form of common sense.
Exactly.
Wow.
And that's where things get really interesting. Because if AI can understand functionality, it opens up a whole new realm of possibilities for how it can interact with the world.
Okay, my mind is officially blown. But I'm guessing even the best AI isn't perfect, right?
Of course, of course.
What kind of limitations did they encounter in this research?
You're right, there are always limitations. One they mentioned is that as scenes get more complex, the computational resources required increase significantly.
Oh, okay.
So there's a trade-off between accuracy and efficiency that needs to be addressed.
Makes sense, like our brains too, right? If you walk into a super cluttered room, it takes you longer to process everything and find what you're looking for.
Precisely. They also found that even with all this spatial reasoning power, the AI still struggles with certain concepts like left-right or front-back.
Really?
It seems those relative positions are surprisingly difficult for AI to grasp consistently.
That is surprising. You'd think those would be basic concepts for AI to understand by now. Why do you think this is such a challenge?
Well, it all comes back to that idea of embodiment.
Right.
We humans experience those concepts in relation to our own bodies.
Uh-huh.
AI, on the other hand, is still learning to understand them in a more abstract, disembodied way.
So it's like AI is still missing that gut feeling we have about where things are in relation to our own bodies.
Exactly, and that's an area where future research could really push the boundaries of AI's spatial understanding. If we can teach AI to perceive the world from a more embodied perspective, I think we'll see significant improvements in its ability to handle those tricky spatial concepts.
I'm really curious to see where this research goes next. It feels like we're just scratching the surface of what AI can achieve when it comes to understanding the 3D world. But before we get too far ahead of ourselves, let's take a step back and recap what we've learned so far.
Sounds good. Let's distill some key takeaways for our listeners before we dive deeper into the implications of this research.
Okay, so first off, we've learned that AI is getting seriously good at understanding 3D space, not just identifying objects. This research is all about combining 3D scene graphs with the power of LLMs to teach AI how to see the relationships between objects and understand the layout of a scene.
And this ability opens up a whole new realm of potential applications.
Oh, yeah.
We're talking about robots that can navigate complex environments, AI systems that can understand the purpose of a room or a tool, and virtual worlds that are as immersive and interactive as the real world.
But it's not all sunshine and roses, right?
Right.
We've also learned that there are still some pretty big challenges to overcome, like the issue of computational resources and the difficulty of giving AI a more embodied understanding of space.
You're right. But even with these challenges, the progress being made in this area is incredibly exciting.
Yeah.
And it's leading to some fascinating questions about the nature of intelligence itself, both human and artificial.
This is definitely one of those deep dives that leaves you with more questions than answers.
Definitely.
But that's what makes it so intriguing. So, for our listeners who are ready to keep exploring, stay tuned for part 2, where we'll delve deeper into the implications of this research and speculate about what the future holds for AI's understanding of the 3D world.
We'll also be tackling some of those big questions about the nature of intelligence and the potential impact of this technology on our lives.
It's going to be a mind-bending ride, so buckle up.
And in the meantime, for those who are eager to get a head start, you can check out the show notes for links to the research paper and other resources.
Happy exploring.
Yeah.
We'll see you back here soon for part 2 of our deep dive into the fascinating world of AI and 3D scene understanding.
See you then.
You know, one thing that really jumps out at me as we go deeper with this research is how much more interconnected all the different fields of AI are becoming. We're seeing like computer vision and natural language processing and knowledge representation all like coming together to create something really remarkable.
That's a great point. It's like AI is finally becoming more holistic, more like how our own brains actually work, right?
Exactly.
We don't neatly like compartmentalize our knowledge into separate boxes. It's all interconnected and influencing each other.
Exactly. And that's why this 3DGraphLLM research is so exciting.
It's like a glimpse into a future where AI systems can understand the world in a much richer, more integrated way.
It really makes you wonder what kind of potential applications are out there that we haven't even thought of yet, you know? What happens when AI can not only understand 3D space, but also reason about time, causality, even human emotions.
Oh, now you're getting into some fascinating territory.
Right.
Those are some of the biggest challenges facing AI research today. And it's certainly intriguing to think about how this kind of spatial understanding could like contribute to those areas.
For instance, imagine a self-driving car that can not only navigate the roads, but can like anticipate how pedestrians might move or how the environment might change based on weather conditions,
Right.
Or think about disaster relief efforts where AI could help like predict the spread of a fire or a flood and guide people to safety.
Those are some really compelling examples.
Yeah.
The possibilities are vast, but of course this research is still in its early stages. And there are hurdles to clear before we see those applications become a reality.
True. So let's talk about some of those hurdles.
Okay.
We touched on the issue of computational resources earlier. As scenes become more complex, the AI needs more power to like process everything.
Right.
What are some potential solutions to this challenge?
Well, one approach the researchers mention is developing more efficient algorithms for representing and processing those 3D scene graphs.
Right.
A lot of research is focused on finding ways to like compress the information in those scene graphs without losing crucial details.
So it's like finding a way to create a more streamlined map that still has all the important landmarks and routes.
Exactly.
Okay, that makes sense. What about the challenge of AI's disembodiment? Any progress being made on that front?
That's a tough nut to crack. One avenue that researchers are exploring is using virtual environments to train AI. The idea is that by interacting with a simulated world, AI can develop a more embodied sense of space and how its actions relate to its surroundings.
Interesting. So it's like giving AI its own virtual playground to experiment in, kind of like those simulations they use to train self-driving cars, but for spatial reasoning.
Exactly. By exposing AI to diverse scenarios in a virtual environment, it can learn to generalize its spatial understanding and apply it to new situations in the real world. This could be a game changer for robots that need to navigate cluttered spaces or manipulate objects with precision.
Speaking of real-world applications. The paper mentions some interesting failure cases where the AI struggled to grasp certain spatial concepts. You pointed out the example of confusing left and right or front and back.
Right.
What other tricky situations did the researchers observe?
Well, one that stood out to me was when the AI was asked to identify a specific bed in a hotel room. The description said the bed was to the right of the nightstand. However, the AI selected the wrong bed.
Oh, really?
Likely because it misinterpreted the perspective of the observer.
So it's like those times when you're giving someone directions and you really have to like think about it from their point of view, not just your own.
Right.
Spatial reasoning can be surprisingly tricky, even for us humans.
It really can, and that highlights the importance of training AI systems on a wide variety of examples, including different viewpoints and perspectives. The more diverse the training data, the better the AI will be able to adapt its understanding to new situations. After all, the real world is full of surprise.
Absolutely. Now, I'm curious about how they evaluated the AI's understanding of those functional queries we talked about earlier. And you mentioned the AI knowing you can't cook dinner in a hotel room. How do you even test something like that? It seems pretty abstract for a machine.
It is. It seems they designed specific queries to assess the AI's ability to reason about the purpose of a scene or object. So in that hotel room example, the AI might have access to data about typical objects in hotel rooms. It would then have to deduce, based on the absence of things like a stove or an oven, that cooking dinner isn't a typical function of that space.
So it's like giving the AI a set of clues and seeing if it can use its knowledge of the world to solve the puzzle.
Precisely. It's like a detective game for AI, where it has to piece together the evidence to reach a logical conclusion. And the fact that they were able to get positive results on these functional queries really speaks to the sophistication of this 3DGraphLLM approach.
I'm impressed by the level of creativity involved in designing these experiments. It's not just about blindly throwing data at an AI. It's about carefully crafting scenarios that test the limits of its understanding.
You're spot on. It's a good reminder that AI research isn't just about cold, hard data and algorithms. It requires a deep understanding of human intelligence and the nuances of how we think and learn.
And that brings up an interesting question. Do you think this research has any implications for how we understand our own brains? I mean, AI is starting to mimic human spatial reasoning. Could that shed light on how our own cognitive processes work?
It's a fascinating question. I'm not a neuroscientist,
Sure.
but I do think there are some interesting parallels
Yeah.
between this research and current theories of cognitive development. The idea that we build our understanding of the world through a combination of visual perception, language, and spatial reasoning is certainly consistent with how we believe the human brain learns.
It's almost like this research is holding up a mirror to our own minds, helping us to appreciate the incredible complexity and beauty of human cognition.
I love that analogy, and it underscores that we still have so much to learn, both about the brain and about the potential of artificial intelligence.
Right.
The more we explore these areas,
the more we realize how much we don't know.
Okay, before we get too philosophical, I want to loop back to something you mentioned earlier.
Yeah.
The ethical implications of this technology. It's easy to get caught up in the excitement of all the cool things AI could do.
Yeah.
But it's crucial to remember that with great power comes great responsibility.
Absolutely. As AI becomes increasingly sophisticated in its ability to understand and interact with the world,
right,
we need to be incredibly mindful of how it's developed and used. We need to make sure that it aligns with our values and that it's utilized for the benefit of humanity, not to its detriment.
It's a powerful reminder that we're not just building tools. We're essentially creating potential agents that could have a significant impact on our lives and the future of society as a whole.
And that's precisely why it's so important to have these conversations now.
Right.
Before this technology advances beyond our control, we need to be proactive
in shaping the development of AI in a responsible and ethical way.
Couldn't agree more. We need to think not just about what AI can do, but what it should do. It's a big challenge, but it's also an incredible opportunity to shape the future in a way that benefits everyone.
Well said. It's a responsibility that falls on all of us, not just researchers and developers. We all have a role to play in ensuring that AI is used for good.
So to our listeners out there, don't just be passive consumers of technology. Be engaged, stay informed, and be part of the conversation about the future of AI. Your voices matter.
I love that call to action. The future isn't something that just happens to us. It's something we actively create together. And with AI playing an increasingly crucial role in shaping that future, it's more important than ever that we all participate in the conversation.
All right, I think we've covered a lot of ground in this deep dive so far. We've explored some cutting-edge research, discussed mind-blowing possibilities, and grappled with some serious ethical considerations. What a journey.
It really has been.
But there's still more to come.
That's right. In part 3, we'll wrap things up by digging into some of the specific failure cases in more detail, and we'll speculate about what the future holds for AI's understanding of the 3D world.
We'll also be discussing some of the broader trends in AI research. And how this 3D scene understanding fits into the bigger picture of creating truly intelligent machines. It's going to be a fascinating exploration, so be sure to join us for the final part of our deep dive. Welcome back, everyone, to the final part of our deep dive into AI and 3D scene understanding.
It's been a wild ride, hasn't it, exploring all this cutting-edge research?
It really has. We've covered so much ground already, from those fascinating 3D scene graphs to the, mind-boggling potential of those functional queries.
Totally.
But before we wrap things up, I want to circle back to those failure cases that we touched on earlier.
Okay, yeah.
The moments where the AI, even with all of its sophistication, still kind of stumbled a bit.
Yeah, sometimes it's those hiccups that reveal, the most intriguing insights. They highlight just how complex spatial reasoning is. Even for something as advanced as AI.
It's a good reminder that we shouldn't underestimate the power of, the human brain.
For sure.
So which failure cases really stood out to you?
Well, the one that I keep coming back to is the AI's difficulty with consistently differentiating left and right or front and back.
Right, yeah.
The researchers use something called a spatial transformer to try and help the AI grasp those relationships.
Okay.
But it seems like there's still work to be done.
I wonder part of the challenge is that those concepts are relative to the observer's perspective, right? What's left to me could be right to you if we're, facing each other.
Right.
Maybe AI needs a more nuanced understanding of viewpoints to truly nail those concepts.
That's a great point. It brings us back to that idea of embodiment. we were discussing earlier. If AI systems could experience the world from a more grounded, like first-person perspective with a sense of their own position and orientation,
Right.
they might be better equipped to handle those relative spatial judgments.
It's like, we humans don't just see a chair. We
Wow.
understand that we can walk toward it, we can sit on it, we can move around it.
Hmm.
We have this intuitive sense of how our bodies interact with the space around us. Maybe AI needs a similar kind of like embodied understanding to truly grasp those finer points of spatial reasoning.
I think you've hit the nail on the head, and that's why I believe this research is really just the tip of the iceberg when it comes to AI and 3D scene understanding.
Hmm.
As AI systems become more embodied, more situated within their environments,
Right.
I think we're going to witness like a truly remarkable leap forward in their capabilities.
It's exciting to think about all the possibilities. But let's kind of shift gears for a moment and zoom out to the bigger picture.
Yeah.
We've been like laser focused on this one specific research paper.
Yeah.
But how does this work connect to the broader landscape of AI? What are some of the key trends and advancements that have you particularly fired up these days?
One trend that I find really exciting is this growing integration of different AI disciplines.
Okay.
We're seeing computer vision, natural language processing,
Hmm.
robotics, even fields like knowledge representation, all like converging in ways that were unimaginable just a few years ago.
Like AI is finally evolving beyond a collection of like isolated tools and becoming a more unified, holistic system, more like our own wonderfully messy brains, right?
Precisely. And I think that that convergence is absolutely essential if we
Yeah.
want to create AI systems that can truly comprehend and interact with the world in all of its beautiful complexity.
It also makes you question our traditional definitions of machine intelligence.
Yeah.
It's no longer solely about crunching numbers or following instructions. It's about the ability to perceive, to reason, to adapt, to learn.
In a way that like mirrors the incredible flexibility and nuance of human intelligence.
It's a profound shift in perspective, isn't it? And it compels us to confront some pretty deep questions about like the very nature of consciousness and what it means to be human. Are we like at our core just biological machines that could one day be replicated by sufficiently advanced technology? Or is there something more to our consciousness, something uniquely human that algorithms and data can never fully capture?
Whoa, that's getting to some serious existential territory.
Yeah.
I'm not sure I have the answers to those questions, but they're definitely worth pondering as we venture further into like the uncharted waters of AI development.
Absolutely. And those questions also underscore the importance of approaching AI with a sense of thoughtful consideration and ethical awareness. It's not just about what we can do, but what we should do. The choices we make today are going to shape the future of AI and its impact on humanity.
It's a weighty responsibility.
But also an incredible opportunity. We have the chance to guide this technology in a direction that benefits all of humanity.
Yeah.
It helps us solve some of the world's most pressing challenges while upholding our values and respecting the dignity of every individual.
Well said. It's a delicate balancing act, to be sure. But with open dialogue, careful planning, and a shared commitment to ethical development, I believe we can harness the extraordinary power of AI for good.
I wholeheartedly agree.
Yeah.
On that optimistic note, I think it's time to bring this deep dive to a close. We've journeyed from the intricate details of 3D scene graphs to the grand philosophical questions surrounding the nature of intelligence and consciousness. What a ride.
It really has been.
It's been an absolute pleasure exploring these ideas with you and all of our listeners.
Likewise.
It's always so invigorating to dive into the forefront of research and contemplate the limitless possibilities that lie ahead.
Absolutely.
Before we sign off, though, I want to leave our listeners with one final thought. The future of AI is not preordained. It's a future that we are actively shaping right now through the choices we make, the conversations we have, the actions we take.
So let's choose wisely, let's act responsibly,
Yes.
and let's work together to build a future where AI empowers humanity, elevates our potential, and helps us create a world that we can all be proud of.
Couldn't have said it better myself.
Yeah.
Thank you for joining us on this incredible deep dive into the fascinating world of AI and 3D scene understanding.
Yeah.
And we'll be back soon with another episode, exploring a new frontier of knowledge and discovery.
Until then, stay curious, keep learning, and never stop questioning.
See you on the next deep dive.